Now, problem number 17 from AC circuit. Let's see the solution of this question. Now, we note down the given first. A 25 microfarad capacitor. So, C is 25 microfarad. So, here it is 25 into 10 raised to minus 6 farad is the capacity. 0.10 Henry is the inductance. So, L is 0.10 Henry. And 25 ohm resistor. So R is 25 ohm. Are connected in series with an AC source whose EMF is given by. So this EMF, this is E0, this is omega, and this is T. So here E0 is 310 volt, omega is 314 radian per second. What is the frequency? First we find out frequency. So frequency we get by formula. So here they given omega. No? So omega is 2 pi f, and so by that formula we can write frequency f is equal to this omega divided by 2 pi. So omega is known here 314 divided by 2 pi. 2 into 3.14. So after solving this we get it is as a 50 hertz is the frequency. So first we already find out frequency. Now after the frequency, second is reactance. Second point, reactance. Now here this is a circuit with capacitor, inductor and resistor, LCR circuit. So reactance means here they connected. First we find out inductive reactance, then capacitive reactance, and then difference in these two is a reactance. So first we find out inductive reactance, which is given by formula omega L. So omega here it is 314, L is 0.10. So after solving this we get inductive reactance is here 314 multiplied by this 0.1, it is 31.4 ohm. Then we can find out capacitive reactance. Also, capacitive reactance Xc is given by formula 1 upon omega C. So 1 upon omega is 314, C is 25 into 10 raised to minus 6. After solving this, we get it is as a 127.4 ohm is a capacitive reactance. But we have to find out effective reactance. Hence, reactance is given by formula XL minus XC. So here XL is less as compared to XC. It only indicates that this is a capacitive circuit. That's it. So here we can substitute. We have to find out magnitude of this or difference of this XL and XC. So here it is, we can write 31.4 minus 127.4. So difference of these two is coming, it is 96 ohm. So here we get reactance. Reactance is 96 ohm. So after reactance, the next part we have to find out impedance. So third part is the impedance. Impedance we can represent by Z. So impedance is given by formula under root. It's a LCR circuit, so R square plus XL minus XC bracket square. Now here we substitute the values. So R is 25, so 25 square. XL minus XC, just we find out it's a reactance, so 96. So directly I substitute 96 square. So here after solving this we get here. So 25 square is 625 plus this 96 square is 9216. After solving this we get it is as a 9841. The square root of that 9841 is coming 99.2 or 20 we can write here ohm. So this is impedance. So here we get impedance 99.2. Now after that impedance we have to find out current and phase angle. Now current, so fourth part is current. So we have to find out RMS current. So first we find out peak value of the current because they given the peak value of EMF here. So peak value of the current I0 is E0 by resistance offered by its LCR circuit, so Z. So E0 is 310 and Z is 99.2. So after solving this, it is coming 3.125 ampere. So this is the peak value of the current. But we have to find out RMS current. So RMS current, IRMS, is equal to IRMS, we can write peak value divided by root 2. So peak value is 3.125 divided by root 2 is 1.414. After simplifying this, we get an answer here for the RMS value of the current is 2.21 ampere. So here we get a current. So IRMS is 2.21 ampere. So this is the RMS current. Also we have to find out the fifth point as a phase angle. Phase angle. So we can find out phase angle by two formulas. So here we can use a formula for phase angle is equal to tan inverse of XL minus XC divided by R. Or if you don't want to use this formula, you can use another one also, that power factor formula. Why this formula? Phi is equal to cos inverse of R by Z. So we substitute here. So we get tan inverse of XL. XL here, XL value is or XL minus XC we have. So here XL minus XC we have 96. So that we can substitute 96 divided by R is 25. So 96 divided by 25, tan inverse of this, or here the division of this is coming 3.84. So tan inverse of this is coming 75.4 degree. So this is a phase angle between current and EMF. So here we find out everything. First we find out frequency, which is coming 50 Hertz. Second one we find out reactance, which is coming 96. For that we find out inductive reactance, capacitive reactance. Then we find out impedance. Then we find out RMS value of the current as well as peak value of the current also we obtained here. So this you can see, this is the peak value of the current. The phase angle we get this 75.4 degree. So if you want to write instantaneous value of this, here they given EMF. Now instantaneous current also we can write. So if you want to write it, you can able to write it instantaneous current also. So we write down instantaneous current. Instantaneous current. So instantaneous current we can write I is equal to I0 sine of omega t plus or minus phi. Now here you can see, as here which one is greater, XL is greater or XC is greater? Here I think XC is greater, sorry, XC is greater than XL. So it's a capacitive circuit. In capacitive circuit current is leading, so I can write plus sign and this is a phase. So I0 peak value of the current we get 3.125 sine of this omega t. You can see here omega is 314. Omega is 314. This t plus phi is 75.4. So this is in ampere. So this is a peak value, instantaneous value of the current. I hope everyone understood how we are writing this instantaneous value of the current.